All right. So who knows what a sigma is? A little bit. A few. All right. Well, it's the basis for what Six Sigma means, and it really just means a measure of variation. So it's the Greek letter that statisticians devise would be our to signify standard deviation, or talking about variance around a process mean. And so it's the basic in essence, when relative to Six Sigma, it's the number of standard deviations from the mean from a mean that the closest specification should be. And so to have a process that is what they consider capable to set a specifications, your goal is to be within that process is a normal variation. You need to be 6 standard deviations from the closest spec to have a Six Sigma process. That just means that I do things consistently. I do it well targeted. I do it consistently so that my process doesn't drift, so that I don't see myself, falling outside of what my customer expects. And whether that's a dimensional specification, whether that's a performance specification, whether that's time that it takes to get through the teller line down at the bank. If you have a Six Sigma organization, you're understanding and trying to say, hey, what are those things that make it so that what the customer expects is that they get it every time, basically. And we talk about 3.4 defects per million as if you are that consistent, your chances of actually not or falling outside of your specification range is so infinitesimal. Who can even get to 3.4 million parts per million? But it's a target. It's something to say, I'm going to understand what causes variation in my process. I'm going to go after it, and by some thought process, by mapping out the process, by understanding what causes, what inputs are changing that cause that output, I'm going to be able to make some improvement and reduce the variation of that process. And in the end, I'm going to be delivering my customer value more consistently. So just a way of looking at it, if we were to measure a process, and let's say this is looking at the number of days to complete orders. Say this is, just for example, this is delivery of books to customers. How many days is, what's your expectation? And so this might, just for example, might be a means to take a look at variation. And this is a graphical way of looking at it. Say our, just the, it's kind of a built-up histogram here, but the red line kind of is a way to kind of predict or put some predictive statistics around what we see, the variability and average time that we have for delivering our book to the customer. And so our goal with a Six Sigma process or a project is to achieve the point where we're so consistent that we are, if this was our customer's expectation, that we are very capable, very consistent in delivery of the product or service that we're providing. This chart is something you guys probably have seen dozens of times, and basically this is a predictive model. This is all based off of normal curve and your normal probability density function and everything like that. And so this is basically predicting a way, they put this sigma number really together to be able to say, if I apply Six Sigma on a very simple process, if I got a pen in my pocket here, if I can improve a product as simple as a pencil, and I can compare that through applying a sigma level. I can compare the improvement that I've seen in a very simple product all the way up to like a IBM mainframe computer with all the aspects of that. And so it's just a means to be comparative as far as looking at projects and what kind of success you had with those at meeting your customers' requirements. So when you start out a project, one of your deliverables in a Greenbelt project is that you're going to assess where you are on this Sigma map. And it's going to be, a lot of times it's going to be based on what is the number of defects I'm creating? How many times am I upsetting my customer? How many times did I go and have to stand in line waiting at the bank teller because they didn't train the person well, because the systems were down, all those things that add to time. So all the customer sees is, hey, I didn't get the service I expected in the time that I expected it. So that would be a defect in this mark, in this way, and that would be an error. And so what this is doing is just kind of giving you some ideas relative to some standard things within life. We're doing 1,000 or 100,000 surgeries, and our process delivered quality at a particular level, at a 2 sigma level. Then we would have 2,275 times where we made an error in that surgery. We didn't left a instrument inside the person when they sewed them up or something like that. That would get pretty bad. You would hope that the level of precision within those industries, if you're doing surgeries, is a lot higher than that. Because it's many times life and death. If I took that bed turns, unscheduled times, this would be, not really sure what that is. And then lights out per week. And so if we were looking at applying it to the electrical system, and we were looking at these levels of performance quality, at a 2 sigma level, we'd be out of power 4 hours a day. And that would just not be acceptable. And so ours is probably a little bit closer up there on between the 4 to 6 range as far as power. Don't know what happens when we have a big thunderstorm like tonight. Let's see. All right. Lean is another set of tools that you'll learn as far as part of the Greenbelt. And Lean is really looking at finding waste within systems. And what is waste within the system?
Extra movements.
Extra movements yeah, that's a good example.
Defective parts.
Quality defects, yes, that's a waste within any system. Yes.
Idle resources.
Idle resources, yes, if they're not being adequately applied, and that can apply towards, not having somebody scheduled or out of time, or not using all of their person. Just giving a person no ability to think and improve their process. And so Lean is another set of tools, and they complement each other. They with Six Sigma, Lean together. And so some of the Lean tools that are specific to just a slight variance on how you would apply this, but the Lean tools also follow the DMAIC process from define, measure, analyze, improve, and control. And these are some examples of some of the specific tools that you might apply if you're doing Lean relative to solve a problem. Right up front, when you're working for a company, you're a certified green belt, your manager comes to you and says, here's a project. They will generally have it defined whether it is best to be solved as a Six Sigma project or more of a Lean project. And so that will, so you'll apply the appropriate tools to solve the problem at that point. So one of the decision points in advance of handing that project off to the belt is going to be, hey, is this Lean or is this Six Sigma? And it goes on what is the benefit that they want to get. From my experience, Lean projects, especially in a